Today we will be analyzing the trends within the Dow Jones Industrial Average. The data set we have chosen is a compilation of the Dow Jones Industrial Average from the years 2007 through the end of 2016, and the Dow Jones Industrial Average is the price-weighted average of 30 significant stocks traded on the New York Stock Exchange and the NASDAQ. Thus, the stock, for the most part, accurately represents the overall well-being of the stock market. This is the main reason why we chose this data set.
The stock price of the Dow Jones Industrial Average has been recorded daily within a set, and it is this daily data that we parse through in order to determine patterns and draw conclusions. We used analysis techniques such as linear regression, the first picture on the far left, outliers, and percent change in order to make these conclusions. Here our hypothesis is formally written out at the top here, but the main points we have in our hypothesis are as follows: the presence of a positive correlation against time and a minimum outlier at the time of the economic recession. This means that we expect the data to follow a positive linear slope throughout its life, regardless of dips within the data. Also, that means that we expect an overall minimum outlier at the time of the 2008 recession. After this period of time, the data is expected to recover and continue in its upward trend.
The first analysis technique we used was a simple linear regression using the least squares method. Looking at the screenshot of the program to the right, it is clear to see that the regression line running through the data shows a positive correlation versus time, and also from the correlation coefficient that we calculated using our program, it shows that the line is an 80% fit of the data. Also, the regression shows that the stock price increases on average by about 856 points per year.
Now, in our conclusions of linear regression, the main idea to be had in terms of what it told us is that regardless of the drops in stock price and the dips, an overall positive correlation was present. Specifically, it shows that it continued back on its upward trend no matter how it behaved. Now, the information this shows us may be used to determine patterns that will continue into the future. And if in fact you extended the period of time we ran the linear regression over, you could have a more accurate depiction as to how it might behave in the future. Do we have any questions about that?
Yes, if this trend were to continue, what would the stock price of Dow Jones be in the year 2050?
Well, based on our model, I luckily ran some calculations beforehand, and if the trend continued, the stock price of the Dow Jones Industrial Average will be about 46,000 points in the year 2050. Any others?
What do the variables X and Y represent in your model?
X represents the number of years since 2007, while Y represents the stock price after X years since 2007.
And we had that labeled on the program itself as well. All right. Go ahead.
Our next form of analysis on the data was looking for outliers, which we represent as minimums and maximums. Minimums and maximums are into two different categories: local or annual, or global or decadal. The local outliers, which represent yearly maxes and mins, are represented by smaller red and green circles. Global outliers are calculated over the entire data set and are represented with the larger red and green circles. By hovering over the data points in our program, you will be able to see what the data point is, meaning what the year it correlates to and the stock price at that time.
Now, conclusions we drew from the outliers. In terms of the hypothesis, the global minimum was in fact at the time of the economic recession. And also, in relation with the positive correlation of the data, the global maximum was very close to present day times, showing that the stock price has actually recovered and continued upward towards the present. Other minimums can be related with world events that cause drops in stock prices. For instance, this red minimum right here is actually at the time of an economic decline during 2015. This minor economic panic occurred because of a devaluation of China's currency, and this caused some ripple effects in the U.S. economy. Relating past events with how sharply the stock market dips can actually help determine how severe future crashes might be. Any questions about outliers?
Yes. What was the year and the stock price at the global minimum?
The year was 2009, and the stock price was about 6,500 points.
What's the significance?
All right, percent change. Go for it, Ian.
All right, our third analysis technique used was percent increase and percent decrease. This analysis technique determines the percentage change of the data per year. Visually, this is represented as a sort of stair-step-like pattern. The horizontal lines represent yearly averages, while the vertical lines represent percent increases and percent decreases, the red ones being decreases and the green ones being increases. Using this analysis technique, more specific trends can be observed within the data. For example, instead of an overall positive correlation using regression, we can now see data increases and data decreases throughout the years.
All right, conclusions off of the percent change. So upon closer examination of the data collected from the percent change technique, it can be seen that a sort of rebounding effect is taking place. So if you look at these two values here, we see at the economic recession's largest decline, it decreased about 20%. Now, once it finally hit its all-time low, it rebounded and increased at almost exactly the same as it decreased. So also, if you look at this, in green here, in the years that were non-consecutive, it continued to rebound based on this. This dropped about 14% and this increased about 12%. So you can see that overall the data fell and then it rebounded back up. So why this is important is essentially the rebounds contribute to the overall positive correlation. If it didn't rebound, then it would go in the negative direction. Any questions about percent change?
How do small drops that do not rebound fit within the theory of rebounding data?
Okay, so smaller drops, if you take a look at this one right here, you can see here there's a big drop in the time of the economic recession. So typically with the rebounding theory, you'd expect it to quickly rebound back, but it essentially will not rebound until it's finished declining. But our theory is essentially that it will eventually rebound no matter how bad it gets. So it can have small periods of only decreasing. Any more questions? Yep.
What's the significance of this rebounding effect?
I kind of mentioned it earlier. It tends to either do two things. It either rebounds and comes back up. You can see it here. It rebounded here, and then it rebounded again. It either rebounds or it increases. So if it didn't rebound, then essentially it would just fall, and it wouldn't have its positive correlation. All right. Oh, so this was the rebound I was talking about. That one as well. And then also, you can see here that our percent change can also show us that it's slowly decelerating as you move along. So that's another trend you can spot. Okay.
In summary, the hypothesis was proven true and new insights were formed as a result of our data analysis. To begin with, the hypothesis, the two main predictions that we had proven true by the first two analysis techniques. The positive correlation was proven true through the linear regression, while the outlier behavior that we predicted was proven true through our outlier analysis.
In terms of the new insights formed, the mean shift data that we collected was incredibly helpful for seeing more specific trends in the data, as I mentioned earlier. Rebounds and acceleration changes were the primary trends that we discovered, but more importantly, creating the program actually gave us an increased knowledge of how to parse through large sets of data.
Before we finish off, I just want to talk about what sources we used and how they were helpful. First off, we used this wonderful book called Doing Math with Python. Even though our program was written in Java, it had a lot of pseudocode and statistics formulas that we used. And also we referenced the Java documentation and the processing documentation for writing the program.